Hello everyone, today in this session we will discuss about the open shortest path first protocol, that is the OSPF protocol. So first of all we have to see the introduction of the routing protocol. So routing protocol generally it specifies how the router communicate with each other. So the routing algorithm they generally determine the specific choice of the route. Okay, so we can see in this flowchart there are different popular routing protocols. So popular routing protocols they are divided into the two types, that is the interior and exterior protocols. So in this interior protocol we are considering the RIP and OSPF protocol. So we have to focus on this OSPF today in this session, that is the open shortest path first. So we have suffered from many of the problems of the distance vector protocol. So that is count to the infinity problem, slow convergence, large update packet, slow response to the topological changes. And for this we need a link state protocol. Now see the introduction of the open shortest path first. So this OSPF stand for open shortest path first protocol. It is a link state routing protocol that was developed in 1991. OSPF was developed as a replacement for the distance vector routing protocol RIP. OSPF protocol it is generally based on the Bellman-Ford algorithm, and this protocol generally used or they work well in the small system. So we have to moving toward the area on which we can be used the OSPF protocol. So the OSPF network can be divided into the subdomains called as area. So a area it is nothing but a logical collection of OSPF networks, routers and link that have the same area identification. Again, the area limit the scope of route information distribution, and it is not possible always to do the route update filtering within an area. So the main benefit of creating area in a OSPF protocol is the reduction in the number of routes to propagate by the filtering and summarizing of the route. So the area which is identified in this OSPF protocol, they are identified from by using the area ID. All the network inside the area must be connected. At the border of the area, there is a special router which is to be used, which is known as the area border router, and it summarizes the information and send to the other areas. So this is all about the areas. We have to know what is meant by the backbone area. So as we have told or we have seen that at the border of the area there is a special router which is to be used. It is the area border router. So we have to see what is meant by the backbone area. So generally the backbone area it combines a set of independent area into a single domain. So the every backbone has the reserved area ID of 0.0.0.0 with having this area ID, and the OSPF backbone area it is also known as the area 0. So in this the backbone which acts as a hub for inter-area transit traffic and the distribution of routing information between the area. Each non-backbone area they are must directly connected to the backbone area, and in this we can say that the backbone area must not be partitioned, and it is divided into the smaller pieces under any failure condition. So you can see in this the backbone it is served as a primary area in the OSPF protocol, and the other areas are the secondary areas, and the router inside the bone inside the backbone area it is known as the backbone router. So you can see in this diagram, so there are number of areas in a one autonomous system. So in an autonomous system we are using here the three areas: area 0, area 1 and area 2. So in this we can say that the area 0 it is the backbone area, and this and we can say that the router which is inside the backbone area. So you can see in this diagram the router which is inside this backbone area, it is known as a backbone router. So this is the structure of the autonomous system. So this is all about the OSPF protocol. Now we have to move toward the OSPF type of links, which link can be used or which links can be used in the OSPF protocol. So in the OSPF, as we have already discussed about the area which is used in the OSPF, so we have to move toward we have to discuss about the type of links which may be used in the OSPF protocol. So in the OSPF protocol, a connection which is called as a link, and we can use the four type of link. So the first one is point to point, second one is transient, third one is stub, and fourth one is the virtual. Okay, so we can see that in the OSPF we are using the four types of link. First one is point to point, second one is transient, third one is stub, and fourth one is the virtual. So move toward the first one link, that is the point to point link. So you can see in this diagram, so this is the structure of the point to point network. So point to point link, it is generally a dedicated link that connect exactly the two communication facilities. So you can see in this diagram the two communication facilities, that is the two router, it is connected by a dedicated link, and this type of link it is called as a point to point link. So it connects the two router without any host or router in between. So we can consider the example, or we can see how or where the point to point link it is to be used. So we can consider one example, that is a telephone line where the point to point link it is to be used. In this, there is no need to assign a network address to this type of link, and in this the router which is act as node, and the link which is which having the bidirectional edges. So this is all about the point to point link. Next one type of link which is used by the OSPF protocol is the transient link. So you can see in this diagram, so the in the transient network, a several router attached to it. So data can enter or retrieve through any router. So we can, whenever we want to retrieve the data or whenever we want to enter the data, so it can be possible through any of the router in the network. So each router has many numbers of neighbors. So you can see in this the D having C and E as a number. So each router in this type of link, it having the many numbers of neighbors. So this is the unrealistic representation by using the transient link, and this is the realistic representation that we can use in the OSPF protocol. Now see the next one type of link which is used in the OSPF is the stub link. So in the stub link, it is connected only to one router, or we can say that the stub link it having a link which is connected to only one router. In this, the data entered and leave through this single router, and it is only one direction. So you can see in this diagram that a stub network, it is a, here we are using the stub link, and the stub link which is connected to only one router. So if we want to enter the data or leave the data through this stub link, so we can use only a single router, and it is only in the one directional. So this is the representation of the designated router. Now we have to see the last one link which is used by the OSPF protocol is the virtual link. So when the link between the two router it is to be broken, and the administrator need or create a virtual link between them. So this type of virtual link it is called as a, or this is type of link it is called as a virtual link. Okay, so whenever the link it is to be created between the router and it is to be broken, and administrator created a virtual link between them, so it is the virtual type of link. So this is all about the four types of link that is to be used by the OSPF protocol. So thank you.